This isn't just another minor upgrade in battery technology. It marks the precise moment when the future diverges from the past. For years, lithium-ion batteries have quietly ruled our technological world, energizing everything from smartphones to electric vehicles to home energy system. But beneath their dominance, problems were growing. Rising costs, safety concerns, and limited access to raw materials began to reveal cracks in the once solid foundation of lithium power. Now, from within Tesla's most secretive research labs, something extraordinary has surfaced. A breakthrough that could permanently dismantle the lithium empire and redefine how we think about energy itself. This isn't a simple replacement, it's a reinvention. What Tesla has created isn't just another battery, it's a new kind of power built on abundance, safety, and raw performance. The aluminum-ion battery doesn't just challenge lithium, it obliterates it. For decades, lithium was the king of batteries, but it was always a fragile monarch. Its chemistry brought volatility, its mining brought geopolitical and ethical challenges, and its structure imposed limits that could never truly be surpassed. Aluminum-ion batteries rewrite that entire story. At the heart of this revolution lies a profound yet simple fact. An aluminum ion carries 3 positive charges, whereas a lithium ion carries only 1. This single difference multiplies the potential of aluminum threefold, allowing it to store and move far greater amounts of energy per ion without resorting to rare materials or complex designs. The advantages don't stop there. One of lithium's most notorious weaknesses is safety. Lithium-ion batteries are prone to forming dendrites, microscopic metallic growths that can pierce internal battery layers, leading to short circuits, fires, and even explosion. Aluminum-ion batteries sidestep this danger entirely. They don't form dendrites at all. They remain stable across an impressive temperature range from about 40 degrees Celsius up to 85 degrees Celsius, far beyond what lithium can safely endure. This means no risk of thermal runaway, no fires, and no need for expensive cooling or protective systems. Safety becomes inherent, not an afterthought. Then comes the issue of supply. Lithium is limited, its reserves confined mostly to specific regions like South America and parts of Asia. That concentration has long created economic bottlenecks and geopolitical tensions. Aluminum, by contrast, is the most plentiful metal in Earth's crust. It's easy to find, inexpensive to refine, and its use sidesteps many of the ethical problems tied to cobalt and nickel, 2 metals commonly used in lithium-based batteries. In every way, chemistry, cost, safety, and availability, aluminum simply outclasses lithium. But the true disruption lies in performance. While today's lithium batteries generally achieve around 250 watt-hours per kilogram, Tesla's experimental aluminum-ion cells are rumored to exceed 5,000 watt-hours per kilogram. That's not a mere improvement, it's a transformation of what's possible. Imagine a Tesla Model 2 that could travel not 330 miles, but over 3,000 miles on a single charge. The implications are staggering. Even lifespan becomes almost unrecognizable in comparison, where lithium batteries begin to degrade after 1,500 to 2,000 charge cycles, typically a few years of daily use. Aluminum-ion batteries are said to endure more than 50,000 charge cycles. That's a lifespan stretching beyond 70 years. This extraordinary durability comes from a phenomenon known as self-healing electrode. While lithium batteries eventually develop tiny cracks that weaken performance, aluminum electrodes repair these microfractures automatically, restoring the battery's integrity and maintaining peak function for decades. It's as if the battery regenerates itself each time it's used. Charging time, one of the greatest frustrations of current EV owners, also undergoes a revolution. Lithium batteries often take close to an hour to reach 80% capacity under fast-charging conditions. Aluminum-ion batteries, on the other hand, can charge to 100% in just 10 minutes without overheating or damaging their structure. The faster ion movement of aluminum and its greater thermal stability make this possible. And the safety improvements can't be overstated. Aluminum-ion batteries don't explode, they don't burn, and they're non-toxic. They're chemically stable even under extreme conditions. Contrast that with lithium's history: thousands of EV fires, countless recalls, and public anxiety about battery safety. Aluminum-ion technology removes that fear completely. When measured across every parameter, power density, charge speed, lifespan, and safety, aluminum doesn't just compete, it renders lithium obsolete. Yet what makes this new generation of batteries truly revolutionary are the unprecedented features it can unlock. The self-healing electrode structure is more than just a durability enhancement. It's a paradigm shift. Micro cracks that would cripple a lithium battery are automatically repaired in seconds within aluminum-ion cells. According to research data, these self-healing events restore nearly all, 99.7%, of the battery's original structure. In some cases, the battery even becomes slightly more efficient after healing, thanks to the creation of improved ion pathway. Imagine a power source that not only recovers from wear but becomes stronger over time. Then there's the immense power storage potential. A single aluminum-ion pack could store up to 2,000 kilowatt hours, enough to power multiple homes, construction sites, or even entire microgrids. In this sense, a Tesla vehicle equipped with such a battery wouldn't just be a car, it would be a mobile power plant. During emergencies or grid outages, Tesla's integrated energy management systems could automatically shift into survival mode, distributing stored power to keep essential systems running for weeks. This transforms an automobile from a means of transportation into a cornerstone of household energy independence. And perhaps the most futuristic of all is deep sleep mode. Unlike lithium batteries that gradually degrade even when not in use, aluminum-ion technology allows cells to enter a crystalline dormant state. In this condition, the battery experiences virtually zero capacity loss, even after a decade of storage. When reactivated, it returns to full operation within seconds, as if no time had passed. This opens the door to a completely new relationship between humans and energy, one in which batteries can lie dormant for years, waiting to be used instantly, with no degradation whatsoever. All these capabilities lead to one undeniable truth. Aluminum-ion technology isn't just about better performance. It's about redefining what energy storage can be. It erases the compromises that have long defined lithium: fragility, fire risk, scarcity, and high cost, replacing them with strength, safety, and sustainability. And that brings us to the present moment, the dawn of what many are calling the new battery era. Back in 2022, Elon Musk hinted that the company's next big energy leap would make things go ballistic within a few years. That time, it seems, has arrived. After nearly 7 years of secretive work inside Tesla's Nevada research labs, the aluminum-ion project appears ready to emerge from the shadows. Reports suggest that Tesla has already begun limited-scale production, and insiders whisper about a potential public unveiling at Tesla's much-anticipated 2025 Battery Day, likely set for September. The timing could not be more significant. Around the world, the lithium supply chain is under immense pressure. Prices have become erratic, environmental regulations are tightening, and mining operations face increasing scrutiny. Meanwhile, consumers are becoming frustrated with EVs that remain too costly, take too long to charge, and rely on materials tied to environmental or ethical controversy. Into this uncertainty steps a new technology that solves all those problems at once. If Tesla's aluminum-ion battery achieves commercial deployment by late 2025, the following year could mark the true beginning of electric mobility for the masses. 2026 may go down in history not as just another year of progress, but as the first year when electric vehicles genuinely became mainstream. Not because of subsidies or hype, but because they finally made undeniable sense. Yet this story runs deeper than just a new battery chemistry. The rise of aluminum-ion energy storage represents a rethinking of energy itself, a shift in philosophy as much as in technology. Lithium's era brought incredible progress, but it also carried heavy costs: environmental destruction from mining, international tensions over resource control, and the perpetual expense of a limited material base. Aluminum-ion energy erases those compromises. It's energy made abundant, clean, and stable, not extracted from scarcity, but drawn from one of the Earth's most common elements. The implications stretch far beyond cars. Imagine remote communities running for decades without reliance on fragile grids. Disaster zones powered through weeks of darkness. Homes and industries backed by storage that never fades, never burns, and never needs replacing. This technology could change not only transportation, but infrastructure, manufacturing, and global energy distribution. For Tesla, the goal is larger than producing a better battery. The company is positioning itself to dismantle the old systems that have defined energy for over a century. Entire industries, lithium mining, cobalt refining, and fossil fuel production, could find their foundations shaken. Trillions of dollars in global investments could become stranded assets almost overnight if aluminum-ion technology proves scalable and cost-effective. The question then is not whether this transformation is coming, but who will be ready for it? As Tesla races ahead, most of the automotive world remains stuck optimizing yesterday's lithium technology. They're chasing incremental gains in a system about to be replaced entirely. The companies pouring billions into lithium R&D may soon find themselves holding obsolete infrastructure. Once aluminum-ion batteries enter the market, lighter, faster, safer, and cheaper, consumers will pivot instantly. Who wouldn't choose a vehicle that charges in 10 minutes, never catches fire, and lasts a lifetime? This isn't the slow evolution of technology, it's the abrupt end of an era. Lithium had its moment, but that moment is over. With aluminum-ion power, Tesla isn't just introducing a new product, it's initiating a new industrial age. Energy will no longer be defined by limitation, but by resilience and abundance. The shift has already begun, and history will remember this period as the moment when humanity didn't just improve its batteries, it reinvented energy itself. So the only question that remains is this: when the world crosses this threshold, will you be standing on the sidelines or stepping boldly into the future?